Okay, for numbers 11 through 20, we are going to reverse the process, and we're going to be taking the name and we're going to put it into its formula. So, number 11, we're looking at dinitrogen trioxide. The fact that we have prefixes there is telling us that how many of each element there is. So, nitrogen and oxygen are going to be your two elements. Dinitrogen means we have two nitrogens. Trioxide means we have three oxygens. And that's it when you have prefixes. Nitrogen is just simply N. Technically, it's a diatomic molecule, although that was not covered in detail in our level. But in upper level classes, you'll notice that there's a group of 7 elements that are diatomic, which means they only exist in pairs. Methane is an organic compound. It's CH4, and we're going to talk about that more when we talk about organics, so you don't have to worry about that one. Alright, for number 14, you'll notice that you do not have prefixes here. That means that we're going to be needing to do the crisscross. So lithium is here, and acetate is a polyatomic ion. So lithium, and then acetate is C2H3O2. By looking at the periodic table, you can tell that lithium is a +1. And then acetate, you know, is a -1. That never changes. Crisscross. And you have lithium 1, C2H3O2 1. Or you could just write LiC2H3O2 and be done. Okay, phosphorus trifluoride. Notice you have a prefix here. That means it's molecular, which means we're not worrying about the charges. So we have phosphorus and fluorine. The fact that you don't have any prefix in front of phosphorus means that you only have one there. And that tri means we have 3 phosphorus. So it'd be PF3. Vanadium 5 oxide. You do not have prefixes here, which means we need to do the crisscross because it's going to be an ionic compound. When we're looking at the periodic table, vanadium is here. You cannot determine the charge of vanadium by looking at the periodic table. So therefore, the writer gave you V to give you the charge of a +5. Oxide, oxygen is here. And by looking at the periodic table, you can tell it's a -2. And crisscross those, and it becomes V2O5. Aluminum hydroxide. Aluminum is here. And then hydroxide is a polyatomic ion, and it means OH with a -1 charge. You do not have any prefixes here, which means that you're going to have to do the crisscross. By looking at the periodic table, you can tell that aluminum is a +3. And then hydroxide, as we just said, is a -1. Keep that in parentheses because when you crisscross, you're going to crisscross outside of the parentheses. To be Al1, OH3, or AlOH3. You don't have to write the ones. Number 18. Zinc is here. And sulfide is here. Sulfur is there. You'll notice there's no prefixes here, which means that we're going to have to do the crisscross method. So we have zinc and we have sulfur. Because sulfide becomes sulfur. It's sulfur with a charge. Now you'll notice that zinc is in the middle of the periodic table. But remember, there are 2 elements within the middle of the periodic table that charges actually don't change. And that silver is always a +1 and zinc is always a +2. Which means you don't need to have, nobody needs to have that Roman numeral there, even though you can't look in the periodic table and determine that. You just need to know that zinc's a +2. And sulfur, by looking at the periodic table, you can figure out that it's a -2. Crisscross and becomes Zn2S2. But you'll notice it's 2 and 2. That means it can be reduced to ZnS. When you do the crisscross method, always check to see if it's reduced. You don't have to reduce it when there's prefixes. Silicon tetrafluoride. Tetra means that we do not care about the charges this time. So silicon and fluorine. There is no prefix in front of silicon, so that means that there's only one. And tetra means that there's 4 fluorines. So it's SiF4. And then silver phosphate. Silver's Ag. Phosphate is PO4 with a -3 charge. That is a polyatomic ion. Remember when we were talking about zinc on number 18? Zinc was here. Silver's right here. It's in the same category. You can't look on the periodic table to determine what it is, but it's always a +1, so therefore nobody ever writes 1 there. And then phosphate is a -3. So we crisscross outside of the parentheses, and it becomes Ag3PO41, or simply Ag3PO4. And that is the end of this worksheet.